All right, you guys, so we are starting on Unit 2 today, which is also Chapter 2. So moving on from Chapter 8, which was Unit 1. And what we're going to be looking at in this unit is properties of angles and triangles. So a little bit of geometry type stuff. So with this section, basically what we're going to be doing is learning some of these properties and then using them as justifications in order to be able to calculate the measurements of different angles in sets of lines, and then later on in triangles and different types of polygons. So in order to do that, basically we need to know some common kind of properties that we see with lines that we'll be able to use as proof of how the different lines connect to each other in terms of measurements. And so we need to know quite a bit of vocabulary in order to do that. So the first thing we're going to learn about is something called a transversal. And a transversal is a line that intersects two or more other lines at distinct points. So here you can see with this setup, we have two lines running kind of somewhat horizontally. They're a little bit offset from each other. And then we have a line that kind of crosses through and intersects with both of them. And you can see that here we have a point where this line is intersecting with one of the lines. And here we have a point where this line is intersecting with this second line. And so this fits the definition of a transversal, where we have one line that's intersecting two lines. You could have more lines, and those intersections are happening at distinct points. So there's two separate points where we see this intersection happening. What I've sketched out here, we have two lines, so the blue, and then we have another line that's crossing through both of those lines. However, because we see that it intersects both of those lines at only one point, so there are not distinct different points where the intersections are happening, we can say that this red line is not a transversal. Okay. Because we only see that one we only see that one intersection point for both the lines, so it's not distinct from each other. The other thing we need to think about is, do you know how many degrees there are in a straight line? Right? So if we were to measure from, say, here to there on a straight line, if you think about a protractor, how many degrees is that going to be? And so we can actually look at a protractor and see the answer to that, right? So with a protractor, you would be starting at one side. So remember, whenever you start on a protractor, you use the number that is 0. And then if I go all the way around to make a straight line, then I end up at 180 degrees, because I'm still using if I started at 0 on the outside measurement, I have to stay on the outside measurement on the other side. So it's 180 degrees. Okay. So we know that there are 180 degrees on, whoops, I'm jumping ahead with my degree symbol there. We know there's 180 degrees on a straight line. And so what you guys are going to be wanting to do quite a bit in this unit is use that fact to calculate angles. So if we look at this setup that we have here, let's say if we have angle A and angle B, well then basically you're starting from here to go up to angle A, right? So there's an angle. And then if you're including angle B, so if we do angle A plus B, you're going all the way around, which is making a straight line from here to there. So then we can say angle A plus angle B. Okay, these little angle signs just tell us that we're talking about the angle, is going to be equal to 180 degrees. So if we were to add these two angles together, whatever their measurements are, we should find that they're equal to 180 degrees. Now you can do this for multiple other spots here, right? So for example, you could say if I went from A to C, because we have the transversal here that we can measure along, angle A plus angle C are also going to be equal to 180 degrees. Okay, now you can probably guess the rest here. What about if I were to do angle B? Well, I've already done it in addition to A. So if I wanted to have angle B add up to 180 in a different way, then I can use the transversal line just the way I did for A and C. So B plus D, angle B plus angle D are also going to be equal to 180 degrees. And finally, on the bottom side here, I can do the exact same thing. So if I start here and go all the way around, I can say angle C plus angle D are also equal to 180 degrees. Okay, now we have a special name for these kinds of angles, and it's called supplementary angles. So it's when you have two angles together, for example, A and B like we saw here, and if you were to add their values together, you're going to get 180 degrees. So if we look at this example here, we have angle A here, angle B here. Angle A is equal to 110 degrees. So that's why I have it pre-drawn out, so I wouldn't have to put you guys through that. So I pre-measured it with a protractor. That's 110 degrees. So using this property of supplementary angles, I can calculate angle B because A plus B equals 180. So then I can say that angle B is going to be equal to 180, which is the total, minus the first angle here, which was 110 degrees. And so then I can find that angle B is going to be equal to 70 degrees. Okay. Now you guys will just have to be a little bit patient with me because I don't always remember to draw in the little angle sign, but even if it's not in there, you should probably be aware that I'm talking about the angle. Okay, and then the other kind of angle we can talk about here is called a complementary angle. And with complementary angles, instead of adding up to 180, so instead of being a straight line, we have a 90-degree angle, and the two angles are found inside of those 90 degrees. So if you add them together, then they're going to be equal to 90 degrees. So again, if we label, let's say this one A and this one B, so together, they're adding up to 90 degrees. So angle A, again, I already measured out, and it was equal to 40 degrees. So now the exact same kind of math applies as we had with the supplementary angles. It's just that we're going to be subtracting from a smaller number. So we can say angle B is going to be equal to, in this case, because it's complementary, it's going to be 90 degrees minus my measurement for A, which was 40 degrees. And so I'm going to find that angle B is 50 degrees. Okay, so keep in mind those words. This is definitely a vocab-heavy unit because you need to be able to use these words when you are providing justifications for different angle measurements. So make sure you have that kind of memorized. You might even want to start making yourself a little vocab page to kind of remember the important vocab, and I'll try to remember to point those out as we come across them when we go through the notes. Okay, so let's try a practice here. So in this practice it says use the information above to predict the measures of as many of the angles in the diagram as you can and justify each of your predictions. So this is basically going to happen quite a bit in this unit where you're going to be expected to be able to make a statement about the angle, like how you would calculate it, and then justify it using one of the rules that we've talked about. So in this case, it's pretty easy because we've only talked about two justifications so far, which is that they're either supplementary angles or complementary angles. So if we look at this diagram here, we're given one measurement, and usually when you're working on problems like this, you want to start out with the one measurement and see where you can go from there. So if we look at 140 degrees here, an obvious thing that we could do based on what we just looked at up here would be to find lines that are going to combine with it to add up to a certain value. Now, just looking at this diagram, we can see that there's not really any 90-degree angles. That's kind of visually obvious. So we're probably going to be looking at supplementary angles. And here we do see we have, if we go from angle A all the way across down here, then that'll be a straight line, right? So basically we can say that A plus this angle should be equal to 180 degrees. So we can say 140 degrees plus angle A are going to equal 180 degrees. And so then, of course, that means that 180 minus 140 would be angle A, which would be 40 degrees. And the justification for that is because they are supplementary. So then you would just write that down in the justification box. Okay. So now we know angle A. How can we figure out another angle based on what we know here? Well, if we had angle A here, then based on the only proofs we have so far, we can do an adjacent one here, because actually angle A and angle B also lay across a straight line. So that means they also have to add up to 180. A plus B, oh, and I'm forgetting my signs again, equals 180 degrees. Okay, so then that means if I want to solve for angle B, it's going to be 180 degrees minus angle A, which we said was 40 degrees. Okay, and so then we can say angle B is equal to 140 degrees. Okay, now in this case, again, this is the only thing we've covered, so this is going to be your easiest justification section ever, because it's going to be a supplementary angle as well. Okay, and then angle C we can also do because B and C again are on this straight line, right? So angle B plus angle C is going to be equal to 180. Angle B plus angle C is going to be equal to 180 degrees. And so again, if we want to solve for angle C, we can say it's going to be equal to 180 degrees minus B, which was 140 degrees. Okay, and so then we can say angle C is equal to 40 degrees, which is also supplementary. Now, based on what we just did, you might already be able to guess what some of the other angles, angle justifications are going to be, because if we look at the angles we just solved for, we found that this angle here was 140, and which other angle was 140? We had A was 40, well B was 140. So look at that relationship and see how they're kind of like opposite across from like within an X, right? And they're equal. Now what about A? We said angle A was 40 and angle C was 40. So what do you think you can infer? Does this look like the same kind of a relationship as this one? It's up to you to decide. We're going to get into more justifications as we move through, but it's kind of a good idea to look at some of these relationships before you get to them and start to kind of get them in your head just based on your own observations. Now we've solved for A, B, and C up here. Is there anything we've done that can solve for D, E, F, and G? Well, so far we don't have like a word that we can use to justify them, because we don't have any angles that are directly adjacent to each other that we have already knew that we can calculate. Okay, so D, E, F, and G can't justify, but the kind of afterthought to that is we can't do it yet. Okay, we will get to a point where we can do that. However, again, if you look at your two sides here, maybe you can look through and see, what do you think, what would you guess some of these measurements would be? Do you think they're going to be related to these measurements? Maybe, maybe not. Kind of depends on the properties of all the lines involved. Maybe you remember some stuff from previous geometry you've done. Take a guess, and maybe after we've gone through some other justifications, you'll be able to look back and see if your guesses were correct or not. Okay, so let's move on to the next section here. So a different type of justification is looking at what we call interior angles. And so with interior angles, there are any angles that are formed by a transversal. So remember, the transversal is the line that goes through two separate lines and it encounters them at distinct points. So any angles basically that lie inside the parallel lines. Okay, so for example here, if we were looking at interior pairs, we could say C and E, right? They're both on the inside. These are our parallel lines. So C and E are both on the inside of those parallel lines. And they're formed by that transversal, right? Same thing, D and F, we could also say are interior pairs. So C and E, and then D and F. So these are interior pairs. Now, as it turns out, we aren't actually too concerned about those particular relationships, because if you look at C and E, do you think it seems like they would be the same measurement? A lot of times a good way to determine that would be to think, are they both greater than 90 or less than 90? Because 90 is a common reference angle that we all know. So if you look at C and E, just take a minute and think to yourself, do you think that they're going to be the same? Same thing with F and D. They're not, right? This one is less than 90, this one is greater than 90. So what we're really concerned with a lot of the times is what we call alternate interior. So interior angles are just both on the inside, but they don't have any particular relationship with each other. If we're talking about alternate interior, then what we're talking about is, let me just grab my highlighter here. So let's say angle C here. Now, alternate means like on the other side, right? So angle C here is on the interior of these parallel lines. Alternate to it would be on the other side of the transversal, and so that would be angle F here. Okay, so we have angle C and angle F are alternate interior pairs. So see if you can think to yourself, what do you think is the other pair of alternate interior? Well, they're going to be on, they have to be angles that are on the insides of the parallel line, so that only leaves D and E, and they have to be on opposite sides of the transversal or alternate sides. Okay, so that would be D right here and E. Now compare these with the ones we just talked about. Do you think that these alternate interior pairs, D and E, do you think they're the same measurement? So if you look at D and E, do you think they could be the same? And same thing with C and F. If you guessed yes, then you're correct. So if these two lines are parallel and you have the transversal running through it, then alternate interior pairs are going to be equal angles. Okay, but it has to be that these two lines are parallel. Now we have the same kind of an idea with exterior angles. So with exterior angles, it could be like A and G, for example. So let's put down A and G, right? Because they're on the exterior of the parallel line. So if these are parallel lines, they're on the outsides of those, A and G. Same thing with B and H, right? Are exterior pairs. But again, we can see A and G do not look like they're the same measurements, right? So what we want to think about again is alternate exterior. So again, they have to be on the outsides of the parallel lines, but we want them to be on alternate sides of the transversal. So they want to be on the opposite sides. So if we start out with angle A here, which angle is going to be alternate and exterior to it? So you should have picked angle H there, right? Because it's also on the outside of the parallel lines and it's on the other side of the transversal. Okay, so we can say A and H. If you want, you can pause the video and see if you can guess the other pair of alternate exterior. So G here, right? It's on the outside of the line, the parallel line, and it's on this side of the transversal, so then its alternate exterior would have to be on the outside of the other line and on the opposite side, so on the right side. So we can say B and G are also alternate exterior. And the same thing is true for alternate exterior as we see with alternate interior, which is basically that if these two lines are parallel, then these alternate exterior angles will be equal as well. Okay. Okay, now we have one other justification to look at here, which is corresponding angles. And with corresponding angles, we have one interior angle and one exterior angle that are non-adjacent, so that means they're not directly next to each other, and they're on the same side of the transversal. So for example, if we consider like maybe an angle right here, then a corresponding angle has to be on the same side of the transversal. So if this one's on the right of the transversal, a corresponding angle has to be as well. And it can't be adjacent to this one, right? So this angle here would be directly adjacent, so it can't be there. So we could look at this one right here. It could be a corresponding, right? So it's not adjacent, and because also this angle would technically be adjacent, right? Because this angle is next to that angle. So this one is one further, it's on the same side, so these are corresponding angles. And as you can maybe guess, well, let's look at a few more pairs of corresponding angles, but start to try and guess, do you think that there's a relationship with these? So another one we could look at is, so let's say we start out with this angle. Well, we know for a corresponding angle it can't be adjacent, so it couldn't be this one. Okay, but if we go one further, it could be, and then it has to be on the same side of the transversal, so we could look right there. Okay, so again, these two are a pair of corresponding, these two are a pair. Do you think you see a relationship? Now, what if we look on the other side? See if you can guess where you would put the corresponding angles. If you want, you could draw them in pencil, pause the video, and then check back and see if you get it right. So another set would be, just like we had here on the inside, we could have on the inside here, and then corresponding would be on the same side of the transversal but not adjacent, so we're going to move, basically bump down one. Or we could do the same thing where we have on the top, right, on the exterior, and then if we move down the line, right here, we would have another one. Okay, so the statement we have for corresponding angles is that when a transversal intersects a pair of parallel lines, so we have this pair of parallel lines, the corresponding angles that are formed by each parallel line and the transversal are equal. Okay, so these sets of angles we all just drew in are all equal to each other. So these two angles are going to be equal. These two angles are going to be equal, which we drew in there. These two are going to be equal. And then obviously these two bigger ones will also be equal. So with the corresponding angles, it's just kind of a good idea to get to be familiar with. Those are basically the sets of corresponding angles. Now, the nice thing with them is that usually it's fairly obvious which ones are corresponding because you can look at the angles and see that they're the same size. Okay. So last thing here, when a transversal intersects a pair of non-parallel lines, the corresponding angles are not equal. Okay, so if we think about this set of lines here, I've tried to set it up the same, so it's A, B, C, D, right? E, F, G, H. So if we were to think about, but in this case, these two lines are parallel. So I'm not sure if you remember from previous geometry, but remember when you see matching sets of arrows on lines like this, so it could be two arrows like that one, or you could have, I think I had that on the previous page. Oh, maybe I didn't. Oh, yeah. Or you could have a matching set of single arrows like this. As long as they match, right? So you can't have one arrow here and two arrows there because then that's not matching. But as long as these two match, it means that those two lines are parallel. Okay. So in this case, we have the double arrows on both. So that means that they're parallel. And let's say we're going to look at this angle here, angle A. What would be its corresponding angle? Well, we know that it has to be on the same side of the transversal, and it's going to be the same angle with parallel lines. So these two would be corresponding angles. Now, if we look over here, these two lines that this transversal intersects with are not parallel, right? So you can still call this a transversal because it intersects at two distinct points on on these two different lines, but it's not, these lines aren't parallel, so the same rules are not going to apply for angle equality. So you can actually see here angle A right there is not going to be equal to angle E the way it was for these two when they were parallel. So for this one, we would say angle A is not equal to, so that's the little like equal sign with a line through it, angle E, because those lines aren't parallel. Whereas with this one, we can say angle E, or angle A, sorry, is equal to angle E. Okay, so a couple of things to just keep in mind for this lesson. Remember that the main justifications you need to know as we move into our next lesson are supplementary and complementary angles, alternate interior. Okay, so we did look at what just interior and exterior angles are, but the ones that we're going to be using as justifications are always alternate interior or alternate exterior. And then the other thing we looked at was corresponding angles, so you should also know those. So 3 things to be aware of as you move forward. And then you have an assignment on page 72 to give a try, and that is just number 2. Okay, and then we'll move on to the next lesson, which is going to be basically moving on with more justifications for angles formed by parallel lines. So I will see you then.